All right, everybody? Hello? Hi, everyone. So, are you live, Peter? Are we live? Just like to welcome everybody here to Definium for the first ever Launceston Silicon Beach greets/guest speaker night, whatever you want to call it. So we're streaming live to Melbourne, so there's a bunch of guys sitting in a room somewhere in Melbourne, anxiously waiting for the great night we're going to have here. And that Mike's going to tell us a great story about all the fantastic stuff that he's doing here from Launceston all around the world. And he's going to give us an exclusive tour of some of the kit that he has acquired that's world class and can compete with anyone in the world really to produce electronics gear. So a bit about Silicon Beach. For those that don't know, it's one of the largest active meetup groups on meetup.com. About 7,000 strong members. Thanks for the 360-degree view there. So there's a real mix of people in that group, from people in startups, people that want to be in startups, people that want to support the network, investors, etc. So it's really great that we can bring that group now to Tasmania. First in Launceston, and who knows, Hobart should hopefully come on board pretty soon as well. So it's pretty exciting. And I'm honoured to have been chosen to stand up here and talk at the first one. So a big thanks to Thula and Alexar and Peter behind the phone at the minute for teeing me up for that. No comment from Peter. The silent assistant. So I guess the idea of these nights is to just talk about some of the great stuff that's happening in Tassie. Launceston in particular, with obviously because it's Launceston Silicon Beach, to show locals what can happen here, and indeed the rest of Australia, that Tasmania is open for business. Not only that, but we can compete globally, as Mike is doing right now, with anyone really on any level. I guess that's it. I'm preparing very well for this. That's great. So I guess that really is a good segue to introduce Mike, actually.
Sure.
To come and give a talk about...
Can we swap?
We can swap.
I'll speak to these people, I guess.
Yes.
Something for speaking to the camera.
So to introduce Mike, he is the CEO of Definium, which is the building we're in. And where are you from originally?
Tasmania.
You are from Tasmania.
Yeah, I've got a messed up accent because I lived in the US,
Right.
in the woods of Europe for about 15 years. We eventually came to my senses and came back to Australia.
Excellent, we're glad to hear you.
Alright, so my name is Mike Cruz, and Definium is our little company in Launceston. We've done something a little bit crazy, I think, which is to create, over the last year or two, year and a half maybe, is that about right, James? A year and a half? An advanced sensor or an advanced electronics manufacturing facility. We'll do a little tour of the lab later. My history, I guess, very briefly, and don't stop that, James. My history is I'm from Tasmania. Yeah, there we go. When it came time for me to get a real job, I had to leave Tasmania. My definition of a real job was to do stuff that I was interested in, and it was very difficult to find work in the kinds of things that I like doing, which was electronics and software. At that time, so I did some consulting in Melbourne, and just through happenstance, I met some people from the US. Decided to go to the US for a holiday to hang out with my friends, and I was offered a job on the third day that I was there, and that was the beginning of pretty much almost a 20-year odyssey. I ended up spending quite a bit of time in the Silicon Valley area, working for startup companies. Eventually started my own, raised angel funding, got investors, and lived that whole roller coaster for a number of years. The economy in the US plummeted for a little while, after a few years, and then I started Definium just as a consulting company, taking on projects that were typically in a state of crisis, where they had a fair bit of money invested in them, and the investors were at a crossroads. Do they cut and run or support their original investment and invest more? And they found myself and a friend of mine, and we would reinvent their solution and do it all with 2 people rather than a team of 12. And that became kind of the theme of Definium, to look at a problem, work with the customer, find a solution that involved a co-design of hardware and software, and we also had the ability to do the manufacturing as well. After coming back to Tasmania, I wanted to continue doing that, and we're a long way from Silicon Valley, but the NBN was imminent for 3 years, and we finally got it though.
Very cruel to say that to people in Melbourne, Mike.
I'm so sorry about that. But not really. Not really. Melbourne still has better shipping. So we don't have an NBN of shipping just yet. So again, I started designing hardware and writing software for embedded devices, for sensors and communications gadgets. And I kept running into a barrier, which is, where do I get my stuff made? And I could sit under a microscope for hours, hand assembling boards like this, and this would literally be a full day's work. And I'd be lucky if I got half of the boards to work. It's not a very good yield, and it's not a very good use of my time. And so I spent more money than my wife would have liked on a small surface mount assembly machine that could pick up tiny little components and put them in the right spots on the board. And a little hand screen printer to print the solder paste. This will make a little bit more sense when we get out to the lab. And it kind of grew from there. Then we finally got some funding with the expert help of someone who can actually write grant applications in the form of James Riggle. My expertise lies in different areas. And we were given a grant of about $500,000 to help fund a project for sensing in the agricultural space. And my goal was to build hardware as well as write the software. And I was originally going to manufacture the easier parts here, and that took a bit of a turn because there was an opportunity to work with the university to put together a really advanced surface mount electronics assembly line. And I wanted to position Definium as the ideal partner for the university to create that kind of capability in Launceston and in Tasmania. And that's kind of where we've gotten to. In fact, we just had all of our new equipment installed as of Friday, so what you'll see here is not only the only facility of its kind in the state, much of the equipment is the only equipment of its kind in the country. And it does, as Dermot said, it allows us to compete on an international stage, and we can build devices that meet the stringent quality requirements of military, aerospace, and automotive type electronics. We're still a small company. In solving the problem of building my own electronics, word has spread, and it turns out we've solved that same problem for a lot of other people. We only just got our new equipment installed on Friday, and we have already, since Friday, or probably since Monday morning, we now have somewhere between 3,000 and 4,000 printed circuit board assemblies that we have to build by the end of the year. And so we are just overwhelmed, but we now have the capability. So I guess in summary, Definium is an engineering, software and hardware design company, and it has not just equipment to do prototyping of boards, but we can actually handle serious volume in many thousands of boards per month. And with that, maybe it's time to go for a little wander to the lab through the dark hall and see if we can make this work on video for everybody as well. I'm sure it'll be fine. Right, so it just takes a few minutes to warm up.
Do you want to tell everybody just what this is before?
Yeah, well, this is kind of the end of the line. In making this kind of electronics, one of the problems that we have, especially with some of the devices on here, is that all the connections are underneath the chip, between the chip and the board. And so when we use these kinds of chips called BGA chips, we have a problem in that we can't see the quality of the solder joints, and so the only way we can do that is with an X-ray inspection system. So we'll come to this last. I'll just get it initializing. I think I can wait for that.
Do we need to wear lens?
No, that's the machine itself weighs 800 kilograms, and most of it's lead. So you'll be okay. Someone could just let me know when that. Oh, there we go.
We'll find out each pretty useful.
Yeah, you become a superhero.
Okay, so the process of making one of these boards is that we'll do a circuit design and then do a board layout. Which is arranging where all the components are going to go on the board, all the interconnections through copper tracks on the board. In some cases there are components on both sides of the board. And then we'll get the blank board made, and this is the only thing that we outsource, is the bare printed circuit board. And I will show you one of those. So here's an example of the bare printed circuit board. And our job at the moment is to try and put all the components in the right places on the board, and it can be done by hand under a microscope, but it is a very tedious and error-prone process. So once we have the bare printed circuit board, we go to the beginning of the assembly line here. And we perform a screen printing operation, and the idea there is to get solder paste onto every pad on the circuit board where we need to solder components. So this machine is a fully inline conveyorized system. Insert the board into the machine, excuse me, and then the board travels into the machine. We can then align the board with cameras inside the machine, and then the stencil will drop down onto the board, and at this point we would have solder paste loaded onto the stencil and squeegee blades, which will do a single pass across the board to print solder paste on the board. And at that point we would have the board, not that we can see it right now, but we would have a tiny deposit of solder paste placed very accurately on all the little gold pads on the board. The next step, and I'll use a different board for this, it would normally travel along the conveyors here. We're just in the midst of setting up for a new board, so we don't have everything set up for that, but we can place the board into the surface mount machine, and I'll just open this up so you can get an idea of the complexity inside. So we have a very advanced machine. It's the only machine of its kind in Australia at the moment, and the purpose of this machine is to pick up the components, and our components typically come in tapes like this, with 5,000 or 10,000 components on a reel. The tapes are fed up through each of the feeders, and then the protective film on the top of the tape is peeled off, and one component at a time is exposed in each of the feeders here. The head assembly in the middle of the machine is then programmed to know which component is where to pick them up, and where to place them on the board. Now, to do the next part, I have to close the cover. Actually, no, I can leave it open and we can run it slow to start with. So, yeah, good to go. So I'm starting the production process just for this one board. The board will travel in on the conveyor shortly, and then the machine will load the appropriate nozzles. And it's going to operate in slow motion. so that you can see kind of what it does. And it operates in slow motion because if you were inside the machine when it was working at full speed, you probably wouldn't make it out. So right now it's taking images of fiducial marks. These are position marks on the board so that the head knows exactly where the board is within a few microns. And so in slow motion, it's picking up components in parallel and it runs around and places them on the board. So this is the slow motion view of it. So I'll close the cover now and you get an idea of what it really does. And if you might be able to get the camera right down into this area here, and you can just barely see the nozzles picking up and shooting the components down onto the board. This is just a dry run at the moment. So it's not actually placing the components because I'd be wasting them because there's no solder paste on the board. But this is a good way to test what's going on. Well, that's actually an image camera. So one of the options I've got on this machine is what's called placement monitoring. I'll show you that in a moment. But for every component that is on the board, it takes 5 photos. Yeah, so it takes one that picks this one before it picks it up in the feeder, one when it's picked it up, one as it moves it, one as it places it on the board, and one afterwards. And I've looked to see if the component is there in the correct orientation or present or not. And if it's not, then it'll stop production. And so this is an inline automatic optical inspection without having a separate $120,000 machine to do it. And it's a great troubleshooting aid as well. Right now, it's actually picking up components from the tray feeding robot. So we can have trays of components. And there's another little head. It'll pick up the components, place them on the shuttle, shoot them into the machine, and then the other head picks it up, holds it over the high-res camera, and make sure that the orientation is correct, and then places it on the board. And that's it. That's 150 components placed at that point. Not on this board, but it would be. At that point, the components are sitting on the board in the solder paste and just being held there by the virtue of the stickiness or the tackiness of the solder paste. Solder paste is just millions of little balls of solder in a flux medium, and the next phase is we have to actually do the soldering. And the way we do that is we use a very special oven, which I don't have fired up right now. And this is what's known as a vacuum vapor phase oven. There is another kind of oven called a convection oven, which just uses heating elements and radiant heat to heat the board. This one heats a special liquid called galvan, and that galvan evaporates or boils at a temperature of 240 degrees Celsius. And the oven heats the liquid so that there's a vapor cloud, and it will lower the board into the vapor cloud. The whole board gets heated up to that temperature, which is the melting point of solder. Once it's melted, it lifts it up into a vacuum hood and exerts a vacuum, and that vaporizes any residual flux and gives us really nice clean solder joints. So there are no voids in the solder joints, which means we get really good connectivity electrically and thermally. And so that's a 6-minute process. So if we put this board in the screen printer at the beginning of the line, approximately 8 minutes later, we have a completely soldered board ready to go. At that point, it's time to load software, do some testing, put it in a little box somewhere, and send it off to track animals, or monitor temperatures, or measure energy, that kind of stuff. So if we go back to the last machine over here, I've still got 3 minutes to go. Dermot, a little jig.
Sorry?
A little jig, 3 minutes.
How long did it take you to do those balls manually before?
Oh, that one panel. I would say that one panel's probably a good 2 hours work, I guess.
Just the whole panel, just one piece of
No, I could probably do the whole panel in 2 hours, okay. I think, and I wouldn't be very happy at the end. And doing that repeatedly is difficult. Now, I've got to make a point though. It's putting one board in, 8 minutes to get through the line. But with all the conveyors, because it's completely automatic and in line, we can have about 20 boards in line. So just like a CPU, you talk about the issue rate at the end when you've got pipelines of instructions, we've got pipelines of boards. Since what it means is that every 6 minutes, we can get about 15 or 16 of those panels through the system, through the oven, and then they're coming out every 60 seconds from the machine. So the oven is going to be the limiting factor. So actual throughput once we start the line is much higher than just one panel every 8 minutes.
So you need James to write you another grant for another hour or something?
He's had enough grants for a while.
but now you mention it, there is a little bit of reporting we have to talk about. Thanks for the reminder. So he said I've got a lot of witnesses here that need to remind us to get that done. So because we've got very accurate, capable equipment, and we have a really good oven, and we can get to this low voiding, really high quality solder process. And one of the things you need to be able to do when you make those kinds of quality statements is prove it. At least we need to prove it to the extent that we can qualify the process through the whole assembly line, and that's why we need an X-ray machine that will be ready in 30 seconds or so. And this is a live X-ray machine, so we can put the board inside the machine and move it around on a transport table and zoom in and out on every little bit of the board, and then run some analysis software at some point, and it'll actually produce the formal report regarding the quality of the solder process.
So before you got on this equipment, what was sort of the error rate that you had?
Unknown. In some cases, yeah. I mean, we would limit ourselves to components that we could visually inspect, and so our error rate was pretty good. We've typically been in the range of a high 90% as far as the yield rate on our boards. Usually, you don't. Most times we've been getting 100%, but every now and again you make a mistake and you get a component around the wrong way. It's not the equipment's fault, but we make a mistake, and then you get 0% yield. And then you're going to go and fix them all and get back to 100% yield again. But when you're producing many boards, you'll get some fallout. But if you can stay in the, I like to be in the 98-99% yield rate all the time. It would be very difficult to achieve that with the equipment that we had before. It was good, and we still use our other machine, but it's referred to as entry level surface mount assembly equipment, or as our vendor says, because I got a couple of extra options, upmarket entry level, which made us feel slightly better. But the equipment we have here is state of the art and doesn't, some parts of it don't exist in the rest of the country. The vapor phase reflow oven, there are only 3, maybe 4 of those in the country, and the other people are people that make bionic ears and electronics for NASA. So we're in that kind of category as far as capability is concerned, and with an X-ray inspection machine that can prove it.
Can we have a Tasmanian space program now?
Well, yeah, this is the kind of equipment that we could actually build CubeSats on. So if anybody wants to build a CubeSat, I'd really like to help them out.
I know a rocket engineer.
So. There we go.
Yeah.
Good. All right, so we actually have. Just move the table around and we'll get the board in there and show you a little bit of what goes on here. It's alright, it's not on now. When the red light's on. I do like this machine because it just looks ominous.
This is the evil lab. You could, couldn't you? You could X-ray yourself.
Just do it yourself.
Yeah, send them in the JPEG.
Yeah, if you can get yourself in there, which I personally would like to see if it's possible. So as you can see, we've got live X-ray images of the board. And this one, we found that we had 20% voiding of our solder joints under the components. might be familiar. So not only can we look underneath chips, we can actually see inside the ICs, and sometimes there are problems that you come across. And so this one in particular is interesting because this is the CPU or the microcontroller unit, and you can see all the connections to the pins, and this is the silicon die in the middle. In fact, it's just bracketed there, so we can see all the way inside the chips as well as look inside the solder joints. So if we I'll go back the other way and try and find something worth looking at.
So do you inspect every board or just take a sample?
No, you don't need to inspect every board, but we do need to qualify the process. The basic assumption is that once you qualify the process, the machine is repeatable enough to give you similar results, but we'll check boards periodically. Certainly the first couple off the line, and then for me, I'll probably check the 5th and the 20th or something like that. If you want to do this as an inline conveyorized operation, then the machine is significantly more expensive. But we don't need to do that part. And the same with automatic optical inspection. There are machines you can get that will look at a board visually, and you can train it to know what's good and what's bad. It'll look at the meniscus on solder joints and the orientation of components and the part names and tell you if something's wrong. And typically that's a spot check again, or you may do every one, but it's a manual operation. But we already have some of that facility, which I haven't really shown you at the moment, the placement monitoring video capture. We'll do that in a moment. Anyway, so I think, just adjust this a little bit. Oh, there we go. So it's a bit difficult to see, but on this particular component, this one had 20% voiding, and there are little white spots there. There's still some tiny voids, but we ran this through the oven again and cleared up all the major voiding under that component, so we can even correct boards that have already been built.
Well, how do you get a figure of 20%? Does it automatically know?
Yeah, so we can go to let's see. So this software was a freebie, which is nice because it's a $10,000 freebie from our vendors, Suba Engineering.
Okay.
But this is the analysis software. So with this software we can mark a particular area of interest, and then we can go to void inspection and do an inspection. And right now it's telling us that we've got about a 4.4% void. It's a bit hard to see there. And now, but what we haven't told it is that this large green one is not actually a void. That's actually a feature of the metal itself. But we can, as you can see, it's recognized that shape, and we can say, okay, discount this. And so when we take that out, then we're certainly below 1% voiding at that point. So it's very smart software, and we can program it to look. You don't have to scan the whole board because most of it doesn't have solder joints, but we can program it to step through the board, looking at all the areas of significance, and then accumulating the total area you've looked at, and then give you a void percentage for the total solder connection area of the board.
So you do repeatable tests.
Yeah, and then you've got load next back. You can mark things good and bad, and it starts remembering. You can see this one's saying good, so it's already done the image recognition and said you're good. 4.4% is quite good.
Yes.
1% is aerospace quality.
Can you just quickly say what is this? Because some people are jumping on and off online.
On this board or the X-ray machine?
Just quickly explain what this is.
So what we're looking at right now is a live X-ray image of one of the circuit boards that we didn't build these ones, but we're helping someone else out, so that we can see the quality of the solder joints in the printed circuit board, so we can determine whether it's going to have a fault in the future. All right, so one last little bit, just so you can see the placement monitoring that we talked about. While the machine was placing all the components on the board, it was capturing 5 images for each component. So when this machine is running full speed, that's a little over 100,000 images an hour, which is why we need a separate machine with a few terabytes of solid-state storage. And just go over here, we can review. see placement. And then beginning. So you can see in this area here, there's a couple of pads labelled for C3, which is a capacitor which is about to get placed. And so it's captured an image of the board before the component's there. And then that's the nozzle placing the component. And that's the component in place. And then we go to the next one. So we have a complete photographic record of every component that's placed on the board. And we might be having a problem where we're picking the components up, so we can go and have a look at the pick images. So this is the tape, and in this area there's a component, and we can, and you see the components now disappeared, and it's in the nozzle up here. So we can watch where it's picking the components up as well. And if we're having a really difficult problem, we can, instead of capturing 5 images, we can capture like a 24 frame a second movie. It takes significantly more storage, but if you're really troubleshooting placing certain components on a board, you can do that. You can also take a board that's been placed and you know it's perfect, put it in the machine, have it train itself on what looks good, and then it will compare the good board to the one that is just placed and tell you if it's good or not.
How long do you keep the images for?
There's about 5 terabytes of storage in here, and so it's probably good for a month. We're doing lots of production like that, depending on you know how many boards are, how many components are on each board. And so there we are. We've got you know a state-of-the-art advanced electronics manufacturing line in Launceston, and it's only a 45-minute flight from Melbourne. So everybody should come right on over, and it's actually a really good thing because if people need things built, it's really good to work with the manufacturer because then you can go through a process called design to manufacturer, which helps you design your board so that it's easy to make. So we take a very interactive approach with customers. And that's,
so if somebody wants to get in touch with you, how would they get in touch with you?
You can look on our website, which is definium.net, and that's probably the easiest way. You can send an email to info@definium.net. I was going to say I shouldn't give my own email address, but they come to me anyway. And so if people need, I think some of the things that we're specialising in, I guess we should say we're not just a contract manufacturer. And we're interested in working with people to build new things, especially in the Internet of Things space, where we're focusing a lot of our energies right now. But we have equipment that makes it easy to build prototypes and small runs. So we don't really have much of a problem with building, you know, like a run of 100 boards or something like that. But we can easily scale up into thousands.
How much would it cost to run 100 boards?
It's very it's very dependent on the board itself. So I'd hate to throw out numbers right now, but we're finding that we're quite competitive. Especially, you know, the alternative is to go to someone in a much more distant place in other countries, and that's a lengthy process with a lot of risk associated with it. And also, we're just trying to build this kind of advanced manufacturing in Australia, and particularly Tasmania. I was both surprised and slightly disappointed to find that there are now precisely 3 surface mount assembly machines in Tasmania, and they're all in this building.
Okay.
Which is a good thing, so now we can do it.
Yep.
Do you want to say some closing?
Yeah, well, thanks, Meg. That was extremely fascinating. So it's
You're somewhat rambling.
Not at all. Very interesting, particularly for geeky people like myself and most of the people here. Even for non-geeks, yes, absolutely.
That's a good point. So you can see that it's not just a big black box somewhere else in another country. This is how it's made, and we can do it here.
Yeah, absolutely. So I think it was a great first night for Silicon Beach and Tassie. So we've set the bar high for the next guest speaker.
Sorry.
You're not.
No, that's good. It was a perfect kind of match for what Silicon Beach is with what we do. So I'm happy everybody found it interesting.
Yep. So if there's anyone in Melbourne that needs some electronics manufacturing done,
45 minutes.
45 minutes away. Or just a phone call and an email.
That's right.
Get in touch. Alright guys, I think we're probably done for the first event here in Launceston. So
We're going to enjoy beers and drinks.
yeah, we're going to go have some beers now. So and some food.
And we, you know, it's still only 45 minutes. I think
Well,
we
you
get
still get here.
Just maybe wave hello to Melbourne.
Bye, Melbourne.
Bye.
See ya.